The next section in measurement is volume. These URLs will give you a visual of the definition of volume of a cuboid, a triangular prism, and a cylinder. Those are the shapes we're going to talk about now. And over here, I've said we're going to look at the volume of rectangles and squares. So that is basically the face that we're looking at, but we talk about the volume of cuboids. Cuboids is a rectangular prism, and a cube is a square prism. Right, volume is far easier than surface area because volume is the area of the parallel face times the distance between the parallel faces. So if we have a look at our rectangle here, and you will see my front face is this, which is two-dimensional. So what I'm going to do, I'm going to area of face, and you don't get any of these formulae in a test or exam, so you need to learn it. Area of face multiplied by the distance traveled. Right, what I mean by the distance traveled is how far this rectangle has got to travel to meet its identical shape at the back. So this one would travel 4 centimeters. So my distance traveled is going to be 4 centimeters. Right, the area of the face, I'm dealing with a rectangle, which is going to be length times breadth. And remember, your length is always the longest side. So it will be 12 centimeters multiplied by 8 centimeters. This is the breadth here. And 12 eighths are 96 centimeters. And that is two-dimensional. Just a quick reminder, two-dimensional. We don't put the D, it's just to tell us it's two-dimensional. And I'm going to multiply by 4 centimeters. And I will get 96 multiplied by 4 is 384 centimeters. And now it is a three-dimensional shape because I have got the whole shape there, three-dimensional. But remember, you don't put the D. So the volume of this cuboid is 384 centimeters cubed. This one you're going to be doing on your own. The next one is the volume of a triangular prism. Triangular prism, why do we have that? Because the parallel faces are triangles. So these two triangles are the parallel faces, and that's where it gets its triangular prism name from. The distance traveled, so the distance between these two triangles is 18 centimeters. Right, the area of a triangle, I'm going to use that. So the area of the face times the distance between, or the distance traveled. Okay, remember when we had a triangle, I said to you the most important part is the right angle, because the right angle points towards the hypotenuse. And then the other thing that the right angle does is that it connects these two sides. So whatever is connected to those two sides, those are the values that you're going to multiply together. And if I have a look here, let me just make it a little bit clearer. So this is my right angle here, which points to the hypotenuse. It connects this side, which is 9 centimeters, and it connects the other side, which is 12 centimeters. So that is the view from the top. The area of my face is going to be half base times perpendicular height. Perpendicular height is to remind you that you look for your right angle sine and connect those two sides. Right, so half times my base, which is 12 centimeters, times by my perpendicular height, which is 9 centimeters. Now, I need to just let you know that if you had written a half multiplied by 9, multiplied by 12, that is also correct. Okay, and the distance traveled, we said, was 18 centimeters. So I'm going to multiply the area of my one triangle, because I'm seeing how many of these must fill that. So it's the area of one triangle multiplied by 18 centimeters. Right, 12 nines are 108. So I'm going to have 108 divided by 2 or multiplied by half will give me 54. So that will give me 54. And remember, your triangle is a 2D shape. So the triangle is centimeters squared, 2D, but we don't put our D on, it is squared. And then I'm going to multiply by 18 centimeters. So 54 multiplied by 18 will give me 972 centimeters. I've got this whole shape that can be filled. So that is a three-dimensional unit. But remember, we don't put the D. So that shape is 972 centimeters cubed. Let's have a look at the volume of, this one's also a homework one for you, real life. Right, the volume of a cylinder. Pardon me with that.